Hi, I'm Larry Whitmer.
And I'm Emily Caggiano, and this is another episode of Dissecting with Emily. And so today we wanted to ask the question, do pelicans have nostrils? And if you look this question up on the internet, the answer you're going to get is no, they don't have nostrils. And when you think about it, it actually makes sense because these birds are plunge diving birds. They're going to plunge into the water from about 20 to 30 feet up. And if they have this open nostril, it's going to get filled with salt water, which really doesn't feel good. And so today we wanted to explore and see whether or not pelicans have a nostril.
Yeah, the kicker with that though is that if you look at the skull, and I'll zoom in right here, you can see the pelicans do have a small bony nostril. It's a lot smaller than what we see in this heron, but it's still a pretty respectable bony nostril.
But if you bring up Nigel here, you can see that it still has this horny covering of the beak, which is called the ramifica, and you can see that what it's doing is actually covering up that opening. And so in these birds, there's actually a difference between what the bony nostril shows and what the fleshy nostril shows.
Yeah, so it makes sense to close off the bony nostril with the plunge diving thing, but the nasal cavity is pretty important. It seems like there must be a lot of cost with closing off the nostril.
And so these birds actually end up giving up three main functions of the nostril when they cover it up. The first being breathing. So these birds can't really breathe through their nose, so they're actually mouth-breathing birds. The second one actually being sense of smell or olfaction, so they can't really receive those signals anymore. And the last one is actually a physiological feature, which is heat exchange and water conservation. So they actually give up all three of these functions in order to close their nostril for the plunge diving.
Yeah, but I'm a bone guy, so I keep coming back to the fact that they still have this bony nostril. And it looks like something's going through there, so what are we missing here?
So they actually have one other function of the nostril. They have a nasal salt gland. And so this gland actually will remove salt from the blood, which is highly important to these birds since they are oceanic birds. So they're surrounded by salt water, they drink salt water, and they eat fish that live in salt water. So they really don't have access to the fresh water that they need to drink in order not to die of dehydration. And so what this gland does is it will remove the salt so that they don't have to, they can still function. And what research has actually shown is that it is actually 4 times more efficient with removing salt from the blood than the kidneys. And so it is a very important gland for them to be able to function as a successful oceanic bird.
And so we wanted to get in and figure out more about what was going on with the anatomy of this salt gland. So what was our next step?
And so what we did is we came back to Nigel, who has been featured in the past few videos that we've done. And again, he was at a rehabilitation center in Florida with a broken wing. He wasn't able to fully recover, so he was euthanized, and that is how we received him. And so what we started off doing is we separated the head from the body, and then we had a few more steps that we did.
Right. Our next step was to enlist the aid of Ruger Porter, who is a PhD researcher in our lab, who's also an expert at vascular injection. And so he helped Emily inject the head of Nigel with substances that allowed us to see the arteries and veins in CT scans. And Emily, why don't you show folks what we found?
And so this is the orbit right here. So this is where the eyeball would sit. And so what we did is we actually removed the eyeball before scanning. And what you can see is that right here in the roof of the orbit is actually a fossa where the salt gland would sit. And if you look below it, you can kind of see that it has these arteries and veins kind of running underneath it, which actually supply it. And you can see that the arteries and veins then continue on into the nostril. And so what we wanted to explore is if the salt gland ducts actually follow the arteries and veins into the nostril as well.
Right, so the next step for us, as it often is in situations like this, is to actually get in there with scalpel and forceps and do the dissection. So Emily, show us what you found with Nigel here, and I'll try to point it out.
So what we did with Nigel is we kind of opened up the orbital cavity here. And if you can kind of rotate this backwards, you can see that the salt gland is in fact sitting in the little fossa right there. And kind of coming off in front of that is the duct of the salt gland as well as the arteries and veins that follow it. And it does go all the way forward right up into that nostril area.
And so I guess we can sort of see that although the nostril is mostly closed off, there still is this one little opening that allows the duct of the nasal gland to actually go and secrete and excrete the salt out of the animal. And so it seems like, although they've lost these other functions, they did retain this one function.
And so you can see by this, you can see how important salt excretion is for these oceanic birds because they were able to give up those other three functions. The one function that they could not give up was a function of the nasal salt gland. And so you can see that they do need a large amount of salt excretion to be a successful oceanic bird.
Yeah, so I guess now we can sort of answer the question that I know was burning in your mind, which is, do pelicans have nostrils? And the answer is actually, kinda. And so with that, I'm Larry Whitmer.
And I'm Emily Casciano.
Thanks for watching.